Hello friends, you're welcome to another episode of our class. Today we have this question to try, and the question says that we should integrate cos x dx. And if you look at that very well, that is an example on definite integral. Okay, now let's look at how we can try this. Recall that anytime we are to integrate from 0 to pi, you have to be aware that pi is radian angle, right? So, and anytime you see pi, it's the same as 180. So from that 180, you can create other angles from it. Like for instance, you can say that 180 divided by 2, that will give us 90. So you have to be sensitive to this. Let's see how we can do this. Now, if we see that it says you integrate from 0 to pi, that is from pi to 180. Now, if you look at your Cartesian plane, the first step we're going to look here is to look at the radian angle. From if a particle is beginning from 0 here, starting from here, when it reaches here, that is what? 90 degree. And 90 degree in radian angle is pi over 2, right? And as we continue to this plane, from here we have pi, right? So we have pi, which is 180. Sum of angles in a straight line. This straight line will give us 180. So if a particle, what I'm saying is that a particle should integrate from 0 to pi. So that means we are going to pass through the first quadrant. The first quadrant and the second quadrant. Now take this in mind. We cannot just jump from 0 to pi here. We have to take the first quadrant and the second quadrant. That is the particles we are going to integrate it from 0 to 90, that is pi over 2, and from 90 to 180. That's what we're going to do here. And this is applicable on any question that's given. So we can say that I is equal to the integral now from what? 0 to 90, that is pi over 2 of course x dx. Now, in the second quadrant, recall that the second quadrant is going to give us minus. So that is minus integral from pi over 2 to pi. Understand that? Of course, x dx. Once we do this, we are done with this question. So that's to say that I is equal to, we can say that this is equal to, if we integrate cos x, we're going to have sine x, right? If we integrate and cos x, we're going to have sine s of, from what? From 0 to pi over 2 minus, because this is in second quadrant, so we're going to have that this is, if we integrate this cos x, we are going to have sine x from what? Pi over 2 to pi. Then you can now open the bracket here. That is to say that I is equal to the bracket of sine, we're coming down sine pi over 2, sine pi over 2 minus sine, the x now here is 0, and 0 minus this minus here of the bracket, we're coming down here of what? Sine pi, that is sine pi minus what? Sine pi over 2. Sine pi over 2. You close your bracket. Now recall that I will be equal to sine pi over 2. That is going to give us 1. That is going to give us 1. And then sine 0 is 0, right? Minus this minus here into the bracket of sine pi is going to be 0 minus sine pi, and pi over 2, that is still going to give us 1. So have I is equal to 1 minus 0 is 1 minus, that is this one, 0 minus 1 is minus 1. So that's equal to this minus give us plus, that is 1 plus 1, and that is going to be 2. That is the answer to that question. And don't forget to like, share, and follow us for more videos on integration and differentiation. See you in the next class. Thank you. God bless you.